this experiment, we are going to look at the buckling of members subjected to compression. We are going to try to understand how buckling strength is influenced by the boundary conditions, modulus of elasticity, and the moment of inertia. What we have here is a setup to apply compressive load and to measure the displacement at mid-height. We are going to consider different boundary conditions here and here, so at the ends of the members. And we are going to use different specimens. You have a total of 5 specimens. And the goal is to investigate how changing from, say, a pin-pin or hinge-hinge boundary condition affects buckling strength versus if it's a fixed boundary condition or if it is a pin-fix boundary condition. So you're going to look at the effect of boundary condition using a circular, a member with a circular cross section, and then you are also going to look at the effect of the moment of inertia for one of the boundary conditions using a rectangular, a member with a rectangular cross section. That would be for the pin-pin case, and you would compare the rectangular cross section to the member with the circular cross section for the same boundary conditions. There is also a member made of copper, and you're going to look at the response of this member with a circular cross section for a pin-pin or hinge-hinge boundary condition. And again, you can compare this with this material to see the effect of the modulus of elasticity. So load is applied using this apparatus, and it's measured using this load cell. And for the first part, you're simply going to measure the buckling strength, but in the second part, you're going to record the displacement at mid-height for different loads to try to investigate the load versus deflection relationship under compression. You can compare the measured buckling strength that you would get from the load cell with the analytical values calculated using the expression in your manual. Please note that the buckling strength is influenced by the boundary conditions, so pay attention to that, and E and I as well.
This is experiment number 6, buckling of compressed members. This apparatus is to hold the specimen in place. This load cell will display the value of the loading applied. This is the midpoint displacement transducer. These are the specimens and fixtures to simulate different boundary conditions. The following 4 fixtures can represent hinge boundary condition. These 2 fixtures can only be used to support the member. Please note that this fixture is to be set here at the bottom. And do not set this fixture at the bottom here. It can only be placed at the top. These are the 5 specimens that we will be using. This is a circular copper rod with hinge-hinge conditions. This is a square steel rod with hinge-hinge conditions. This is a circular steel rod with hinge-fixed conditions. This is a circular steel rod with fixed conditions. This is a circular steel rod with hinge conditions. Use a metal ruler to measure the length of the specimen and mark its midpoint. Set the displacement transducer against the midpoint of the specimen. Use these fixtures to represent hinge condition and set it on top. Then place the specimen into the test apparatus. Make sure it is vertical. After the specimen is set, attach the displacement transducer to its midpoint. Set the displacement transducer to 0. Turn this knob to apply loading to the specimen. Note the values on the midpoint displacement transducer and load cell. Keep adding loading by turning the knob on top. Increase loading till the value on load cell is not linearly increasing. The value on the load cell is the buckling strength of specimen. Note it. When finished, unload the specimen from the test apparatus and replace it with a new one. Repeat the process. After all specimens are tested, remove the specimen and boundary fixtures. Return the test apparatus to its original state.